If you've ever built an AI application, you know that feeling, right? The demo looks absolutely amazing, but then you get it out into the real world and it can be, well, frustratingly unreliable. Today, we're going to break down exactly why that happens and dig into a discipline called context engineering. It's the key to building AI that's not just clever, but actually dependable. This quote just nails it. It really hits home for anyone who's tried to take an AI from a cool, look what this can do demo to a real world product. That magic you see on day one can disappear so fast, leaving you with something brittle and unpredictable. And you're just left scratching your head wondering what went wrong. So, what is the real issue here? Why do so many of these promising AI projects just stumble the second they leave the lab? Well, the surprising answer is that the problem usually isn't the model itself. Nope, it's something much more fundamental. This slide just captures the difference perfectly. On the left, you've got this frustrating bot with no memory. It has zero context. You've probably talked to one of these. But on the right, you have a genuinely helpful assistant that knows who you are, it knows your order history, and it's already guessing what you need. The key difference here isn't a bigger, fancier model. It's a smarter system that gives the model the right context at the right time. Think about all the classic ways AI fails, right? It makes things up. We call those hallucinations. It gives answers that are completely off topic, or it just gets stuck in a loop. These aren't all separate random issues. They are all symptoms pointing back to one single critical flaw in the system's design. And here it is. This is the root cause. The system failed to control the context. It's not about the model's general knowledge of the world. It's about what your application is telling the model to focus on for one specific task right now. Without that tight control, you're basically just rolling the dice on the output every single time. Okay, so this brings us to the solution. And it's a discipline that is totally shifting how we build AI systems. We're moving away from just, throwing a prompt at a model to actually engineering the entire information world around it. Welcome to the context revolution. So a lot of us are familiar with prompt engineering, right? Tweaking the exact words you send to an LLM. But that's kind of like obsessing over the quality of a single brick. Context engineering is about designing the entire building. It's a huge shift from just crafting one query to architecting a whole system that manages context as this dynamic, structured, and most importantly, governed resource. So to put a formal definition on it, context engineering is the systematic practice of designing and managing all the information an AI needs to get its job done right. And this isn't just about the prompt. It includes all the documents you retrieve, the user's history, system instructions, the whole shebang. It's about being deliberate instead of just being accidental. And here's why this is such a game changer. It's dramatic. Teams that really implement proper context engineering often see a 30 to 40% jump in their response accuracy. I mean, that is a massive improvement, and it's often done without even touching the underlying model at all. So how do we actually put this into practice? How do we move from just throwing information at a model to actually methodically engineering its context? Well, it starts with thinking like an engineer and managing constraints. Probably the most powerful way to think about this is with a great analogy, the context budget. Every single AI system has finite resources. You can't just stuff an infinite amount of information into the model's context window. You have to make smart, deliberate trade-offs. And this budget is balanced across four critical areas. First, you've got token space. That's the physical size limit of the model's input. But just as important is latency. How fast do you need the answer? Then there's risk, making sure you're not leaking private data. And of course, there's cost, because every single token has a price tag. A well-engineered system is constantly optimizing across all four of these. The real art of context engineering is in how you allocate this budget. A really common best practice is to reserve about 30% for your system policies and instructions. Think of these as the guardrails or the rules of the road. And then you dedicate the other 70% to the dynamic data, the stuff the model needs for reasoning, like facts you've retrieved and the user's current state. This grounds the model in reality while giving it the evidence it needs to perform. And this all comes together in what we can call a context supply chain. You see, it's not a single action, it's a whole multi-step pipeline. You start by registering your data sources. Then you normalize and enrich them. You index them so you can find them fast. You create a plan for fetching the right info. And then finally, you package it all up in a structured way for the model. This is how you turn chaos into an orderly, efficient pipeline. Now, there's a big question that hangs over all of this. It's the elephant in the room. With all these new models coming out with massive million-token context windows, does all this engineering effort even matter anymore? Can't we just dump everything in and let the model figure it out? I mean, this is the temptation, isn't it? Just throw the biggest, baddest model at every single problem. It feels like the simplest path forward. But the data reveals a really crucial trade-off between performance and efficiency that you have to know about. Okay, so let's look at the data. At first glance, this chart seems to have a clear winner. The orange bars, those represent the long context models, and they consistently get the highest performance. They do better than retrieval augmented generation, or RAG, where the system fetches relevant info first, so it seems like just giving the model everything at once works best. Or does it? Well, that performance comes at a massive cost. This chart shows token usage, which is basically a direct proxy for how much you're paying. The long context approach is our baseline, 100%. But look at RAG, that core context engineering technique. It gets pretty close in performance, but uses only 17% of the tokens. That small performance edge you saw is incredibly expensive. And the takeaway here is crystal clear. The goal is not to find one giant, expensive model for every single task. The goal is to build a smart system that strategically uses the right resource for the right job, balancing performance, cost, and speed. And this really points to the future of AI architecture. It's about building smart, mixed model systems, not just relying on one giant monolithic model to do everything. The winning strategy is called model orchestration. You use smaller, faster, and way cheaper small language models, SLMs, for maybe 80% of your routine tasks. And then you bring in the big guns, the powerful, expensive large language models, or LLMs, selectively, only for that 20% of tasks that genuinely need that high-level reasoning power. This is how you build systems that are both incredibly capable and actually cost-effective at scale. So please, don't chase a bigger model just to fix your problems. Focus on engineering your context first. A well-designed system that feeds precise, clean information to a smaller model will consistently outperform a lazy system that just dumps messy data into a giant one. If you take away just one single thing from this, let it be this. Context quality frequently matters more than model size. Your biggest point of leverage, your biggest opportunity for improving your AI, it isn't the model, it's the context you provide it. So as you go back to building your next AI feature or your next application, ask yourself this question. Are you looking for your next breakthrough in a bigger, more expensive model? Or are you going to find it by building a smarter, more efficient system that truly masters the art and the science of context?